Hello everyone. This lecture is all about the network topology. And as you can see on the screen, there is a very good article on this particular topic. And this article is a recent article which is published by DNA Stuff. As you know that whenever I give such articles, I also quote the basic source of this article. So you can find this article on Google, and I have just made sure that this can be used for academic purpose. Now, basically, we are going to discuss the network topology. And after defining what is computer network, the network topology is a very important concept. Now, as you know, that computer network can be arranged in number of ways, and the hardware, software, the nodes, there are a lot of varieties as far as the network is concerned. So, this network topology it actually specifies the physical and logical description of how the links are there in the computer network and how the nodes are connected by using the links. And the basic definition of topology we will be defining very soon. And after defining the topology, we'll see the various types of network topology also. Because as I said, that this network can be arranged in a variety of ways, the physical arrangement of the network as well as the logical arrangement of the network. So the network topology refers to how various nodes, devices, and connections on your network are physically or logically arranged in relation to each other. You may think your network as a city and the topology as the roadmap. Now you might be knowing that city can be arranged in a variety of ways, and then there will be a roadmap how the city grows. The similar analogy can be applied to computer network, wherein the computer whenever you design a computer network, then you are starting with few nodes, and then you'll be scaling up the network. So then, how do you do that? So basically, there is a very systematic process, a very strategic process for designing the computer network. Because as the number of users are growing in size, the network also grows in size. So therefore, unless we adopt a very good process, very strategic process of defining the computer network, designing the computer network, we can't design very successful network. And that's why there is lot of importance for network topology, because this is how the nodes, devices, and connections are arranged as far as your computer network is concerned. Basically, there are two approaches to network topology. One is physical and other is logical. So you might see on the screen that physical network topology is nothing but it refers to the physical connections and interconnections between the nodes and the network. The network is consisting of wires, cables, then network interface card, and so many things. Okay, and how they are connected physically is all about the physical network topology. While whenever you design a network on the paper, then there exist a logical connections of all these components, and this is called as logical network topology. So it might be different than the physical network topology. So more often, the logical network topology is all about the conceptual understanding of how and why the network is arranged, and how the data moves between the nodes. So that is all about the logical topology. So both the things are very important. Whenever you design the computer network on paper, then the logical topology is important. And whenever you put it into practice, then the physical topology plays a very important role. First of all, why at all this network topology is important? So this is very important because, as I said, if you design the network in a very strategic manner, then you can cater to the number of people, number of users of the network. As the number of users are scaling up, you can also easily incorporate the increased number of users in the network if the network topology is proper. And therefore, it is very important to have a very systematic network topology. The other reasons are if you want to locate the faults on the computer network, if you troubleshoot the errors, and if you want to allocate the resources to the entire network, then your network topology is important. So what's important is basically uh, the troubleshooting. Designing the network is one of the things, but more important is troubleshooting the network whenever there is certain faults, certain problems in the network. So in that case, if your logical design and the physical design is proper, then you can very easily locate the fault in the network. You can troubleshoot error in the network. Now it may happen that in your network, few users they want data intensive applications, bandwidth intensive applications. So in that case, for them you can allocate more bandwidth. So that is called as resource management. Few users might need more data for saving, more memory for saving. So in that case, you can allocate more memory for them. So in this way, the resource allocation becomes very easy whenever you design a proper topology of the network. And we already defined there are two ways to specify the topology. One is physical. It refers to the actual connections, the wires, the cables, the nodes, how they are arranged. So that is actually the physical topology. And basically, while designing the physical network, what's important is how the setup is going to be run, the maintenance issues, and provisioning the tasks that requires a lot of insight as far as the physical network is concerned. The logical network topology is at abstract level, it is at higher level. So whenever actually you roll down the network design, then you can sit with a paper and pen, and then you can start working on the logical network topology. And that includes even the virtual and cloud resources. You know that today everybody is talking about the cloud computing. So the cloud resources, they play a very important role, and therefore the virtual and cloud resources, they also become a part of the logical topology. So please bear it in mind that effective network management and monitoring requires a very strong grasp of physical and logical topology, and therefore this lecture is very important, I would say. And designing the proper topology will ensure that your network is efficient and healthy in terms of the bandwidth usage, in terms of the resource allocation, in terms of the maintenance, in terms of the troubleshooting. All these things becomes very easy if you design the network with proper topology. So let us move towards some more things regarding the topology. We already defined the logical and physical topologies, and we have also pinpointed the issues why this topology is very, very important. Now, what are the common topologies? You can see in the diagram that if you study or if you study the design of any network, then you might fit that network into one of these things, but not necessarily. The practical networks many times differ from the theoretical ones. But since there must be some basic theory we should lay down for designing the network. So, for the sake of theoretical details, you can define the network topology into various types. So, there could be a point to point network having only two nodes. There could be a bus like network. You can see in the next diagram this particular network. This is a bus type network. There could be a ring type network. You can see the ring, the logical ring. There could be a star type network wherein the active device is at the center and all the nodes are at the periphery. See here, when you can see a network printer here. There could be a tree type network. You can see that this resembles like a tree. So basically a tree, and there are a lot of branches with the nodes. There could be a mesh type of network. So there exist many connections, alternate connections, and it looks like a mesh. Okay, so this is a mesh type network. And more often, a combination of all these things exists in the last type of network topology, that is called as hybrid network. So roughly, very roughly, you can define the network topologies into seven types: point to point, bus, ring, star, tree, mesh, and hybrid. And you can also see that the names are given on the basis of the shapes, on the basis of the arrangement of the physical devices, the cables, the nodes. Okay, because for instance, the ring means it resembles like a ring. Star means it resembles like a star. So in this way, the names are given to the network. A tree means it resembles like a tree. Okay, and most important that the practical networks might differ from the theoretical ones. So you read this particular. This is also available if you just open the DNA stuff. Then you can get this article. It's very good article, very recent article published in 2019. And the most important thing, as I was telling you, that there is nothing like one size fits all option. Okay, so whenever you actually you go through the network, go through the network designing, then there are a lot of issues, lot of purpose for which the network is being designed, and there are pros and cons also. So basically, based on that, the network topology is chosen. Okay, so please give me a while. Be now. Uh, I'll be now describing you all these network types. The first of all is we'll start with the star topology, and then one by one we will go with all other topologies.